So hello everyone, we are here to discuss a few problems related to polynomials chapter in class 10th, and again the basis is Eduwiser's book for class 10th, and we are going to refer to the questions that are there in the objective question section of your book for the second chapter. So we'll be picking up few of the critical questions and solving them here, and they will also cater to a few concepts that you would probably appreciate better after understanding these questions. So the first one is like the numbers would be question 1 and 2 and 3 here, but they might not be the same as in the number in your book. So you'll have to figure out which problem number is it. But all of them are from the objective questions for practice for this particular chapter. Now the first question is, if alpha and beta are the zeros of a polynomial px, then which of the following is not true? So there are 4 statements given and we have to pick out which is not true. Now when alpha and beta are zeros of the polynomial px, then we know that p alpha and p beta will be the zeros of the polynomial, and by zeros we mean that p alpha will be equal to p beta will be equal to 0. That is what 0 would mean, right? So in that case, p alpha plus p beta will be equal to 0, which is correct. P alpha minus p beta, again 0 minus 0 is 0, so this will also be correct. P alpha into p beta is 0 into 0, which will again be 0, hence this is also correct. But p alpha by p beta, 0 by 0, p alpha is 0 and p beta is also 0. So 0 by 0 is not defined in mathematics. A number whose numerator and denominator are both exactly 0 is not defined. Denominator can never be 0 in mathematics. The denominator can tend towards 0. When you go to class 11th, you'll be learning about limits, and in that case you would know that the denominator can tend to 0. It cannot exactly be equal to 0. So in mathematics, take the ground rule that the denominator can never be exactly equal to 0, which is what they are trying to imply here. Hence this statement is not true and we will be marking out D as the correct option. The second question is, a polynomial of degree n has only 1 real zeros, exactly n real zeros, at most n real zeros, and more than n real zeros. Now for any polynomial of degree n, we can write it as this, which is what you have learnt in the definition. So this is a polynomial of degree n. It will have n zeros. This polynomial px has n zeros, exactly n zeros. This statement would have been correct, but it's not saying exactly n zeros, it's saying exactly n real zeros. A polynomial may or may not have all of its zeros as real numbers. If you remember the graph that we draw, using graph we find out how many zeros of a polynomial are there. We see that only the real polynomials are plotted on the graph because it is a real number line. So a quadratic, for example, a quadratic polynomial could also be like this. It may not touch the x-axis and hence it will have 0 real zeros. Although we know that a quadratic polynomial has 2 zeros because the degree is 2. So it will have 2 zeros, but the number of real zeros are 0. So any polynomial of degree n will have exactly n zeros, but they all may not be real. So this option is wrong. Only 1 real zero is wrong because of degree n it will always have n zeros. Whether it will have exactly 1 real zero, we do not know. So we cannot say that this is correct. Exactly n real zeros is also wrong because it might be a case where all the zeros are not real. They might not be real. So this is also not certain. At most n real zeros, which is correct. There are n zeros, they all could be real, they all may not be real, but there is a possibility that they all could be real. So at most would mean it will have a maximum of n real zeros. The number of zeros of a polynomial px of degree n cannot exceed n. So it will anyways have at most n real zeros. So this will be a correct option. More than n real zeros is obviously wrong, because any polynomial of degree n will not have more than n zeros. It will have n zeros only. Those n zeros could be real or they may not be real. So it will be at most n. Now let us take up these three questions. It says, the first one says the number of polynomials having zeros as -2 and 5 is. What is the general method, form of a quadratic polynomial whose zeros are given? It will be of the form, this will be, if we are talking only about the quadratic polynomials, if -2 and 5 are the only zeros that it has, then the form of that quadratic polynomial will be this, where alpha and beta are the zeros. So instead of alpha we have -2, so this will become +2 here, because it was minus alpha, so -2 will be +2, and instead of 5 we have beta here, so we replace beta by 5. So this will be the standard form. A is any real number. So if you go on changing the value of A, you will keep on getting different values of the quadratic polynomial. You will be getting different quadratic polynomials. Or for all of them, the polynomial zeros would be the same. So if we keep A as 1, the polynomial will be x plus 2 into x minus 5. If you make it 2, it will be 2 into x plus 2 into x minus 5. So there will be n number of quadratic polynomials. For all of them, the zeros will always be -2 and 5 only. So the answer to this would be infinite. You can go on changing the value of A and you'll keep on getting a new quadratic polynomial. For all of them, the zeros are going to be -2 and 5 as per the given form.